So let's look at a couple more examples where we are going to determine if a number is rational, if it can be written as a fraction, or if it's irrational, meaning it can't be written as a fraction. And in the last video, we talked about how if the decimal terminates, so something like 0.38, it could be written as a fraction. Since this is in the hundredths place, this is really just 38 hundredths. So a terminating decimal is a fraction, is rational, but also a repeating decimal is rational as well, though we have to use a little bit of a trick to be able to figure that out. So let's use that trick again, and we'll have to modify it a little bit, but it will still work. So remember that this number, 0.151 repeating, is really just 0.151, 151, 151, on and on forever. That block of digits, 151, will just keep repeating. So let's call that some letter. Let's say that B is equal to 0.151 repeating. And we want to multiply this by some power of 10, and that determines on how many digits you have in this repeating expression here. So we have 3, so we're going to multiply it by 10 to the third power, or in other words, we're going to multiply it by 1,000. So 1,000b, and the reason we do this, now let me just extend this further, since we know 151 comes after that, and technically 151, 151 would repeat forever as well. So we want to extend that because when we multiply by 1,000, the decimal will move 3 different times. So what we get is 151.151, and again that 151 at the end for the decimal is going to repeat forever. And we do this so that we can take the new number, 1,000 times our original number, so 1,000b, and we're just going to subtract b from that. And of course, this will give us 999b, but let's actually subtract the decimals here. So we have 151.151 repeating minus 0.151 repeating. So for the decimals, they're all going to cancel out. Since this 151, 151, 151, all the places will line up, and every time we subtract, 1 minus 1 is 0, 5 minus 5 is 0, and 1 minus 1 is 0. And that would occur for all of the repeating digits. They all line up, and they all subtract to 0. So the decimal part goes away, and we have 151 minus 0, which is just 151. So we found that when we take our new number and subtract the original one, that it's equal to just 151. So we can solve for b here by just dividing each side by 999. So b is, 151 over 999. And this is something you can check in your calculator, and you'll get back this infinitely repeating decimal. So depending on how many places you have that are repeating, so let's say you have 0.23485, so that's a 3 there, and this is repeating. You have 5 places here, so you would need to call this some letter and then multiply by 10 to whatever place that is. So 10 to the 5th power. So a 1 followed by 5 zeros, which is 100,000. And by multiplying it by 100,000, you move the decimal 5 different places. I think I skipped one there, but it would be 5 places, and you get 21385.21385, and that decimal will be repeating still. So that's the trick. You would subtract these and then line them up and subtract it like we did here, and you'd be able to solve for what that fraction is. So if it's a repeating decimal, it will always be a rational number. It's only when the decimal is infinite and it doesn't have a pattern to it, it does not repeat in any way, then it will be an irrational number. So something like the square root of 2 is 1.414, and there is no pattern to this. If you throw this into the calculator, you'll see that the digits are effectively random, and it does look like it's repeating here with the 4, so really I should go out one more place. So square root of 2 would extend to 1.414, 2, 1, 3, 5, and so on. And eventually your calculator is going to round it. So the calculator will make it seem like it ends, but it's just rounding it because this is an infinitely long decimal. And you see that with a number like pi, where this is 3.14159, and it goes on forever without a pattern. So these irrational numbers, they are decimals that are infinite, but they don't have any repeating. And so that's a way to identify the irrational numbers. And let's look at one more of these examples. So in this one, you can see we have a terminating decimal. And remember that decimals that end can be written as fractions. So 0.692. So just think about the place values. This is the tenths, the hundredths, and the thousandths place. So really we have 692 thousandths. So we can write that as 692 divided by 1,000. And you can check that on your calculator, plug this fraction in, and you'll see you'll get back this exact decimal. And since this can be written as a fraction, we can conclude that this is a rational number.